Do you know how elements are grouped in the periodic table? In this video, I'm going to discuss how elements are grouped into group, period, and block in the periodic table. And also, I will share the valence electronic configurations of elements in S block, P block, and D block.
Elements in the periodic table can be grouped into vertical rows of elements based on the number of valence electrons each element has. For example, for group 1 element, all of them have 1 valence electron. Therefore, they are being grouped into group 1. Followed by group 2, all the elements have 2 number of valence electrons. Then group 3 having 3 valence electrons, group 4, 4 valence electron, group 5, 5 valence electron, and until group 18, which has 8 valence electron. Elements in the periodic table can also be grouped horizontally based on the highest principal quantum number or number of shells filled with electron. For example, in period 1, 2 elements, hydrogen and helium, both of them has the highest principal quantum number equal to 1 and consists of 1 shell filled with electron. Therefore, they are being placed in period 1 in the periodic table. For period 2, it consists of 8 elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. All these 8 elements are being put in period 2 because their highest principal quantum number is equal to 2, and all these 8 elements have 2 shells filled with electrons. Followed by period 3, all these 8 elements has highest principal quantum number equals to 3 and therefore consists of 3 shells filled with electron. So therefore they are being placed in period 3 and so on until period 7, where the elements consist of 7 shells filled with electrons and therefore has highest principal quantum number equal to 7. Therefore those elements are being placed in period 7 in the periodic table. Elements in the periodic table can also be grouped based on block. For group 1 and group 2 elements, they are in the S block because the last electron in the group 1 and group 2 goes into the S subshell. Group 13 until group 18 elements, they are in the P block because the last electron go into the P subshell. Group 3 until group 12 elements belong to D block because the last electron for these elements in D block go into D subshell. For lanthanide and actinide, they are F block elements because the last electron for these elements go into the F subshell. Now we move on to look at how to write the valence electronic configuration for the elements in the periodic table. For group 1, the valence electronic configuration is NS1, and the N here is referring to the highest principal quantum number or period of the element, and the S here is referring to block. Remember, for the group 1 element, the last electron goes to S subshell. Therefore, group 1 element belong to S block, and the 1 here is referring to number of valence electron. For group 1 elements having 1 valence electron, therefore it is superscript 1. And for group 2 elements, the valence electronic configuration is NS2. Again, the N here referring to the highest principal quantum number or period, and S refer to the last electron go into S subshell. Therefore, group 2 element is the S block element. And the superscript 2 here referring to the number of valence electron. Group 2 elements having 2 valence electron, that's why it is superscript 2. indicating 2 valence electron. So now we move on to look at the example. For example, potassium, element potassium. So how do we write the valence electronic configuration for potassium? So potassium is in period 4. Therefore, the valence electronic configuration is 4, and it is in group 1, so S block, so therefore it's 4s, and group 1, 1 valence electron, therefore the valence electronic configuration is 4s1. And how do we write the electronic configuration for potassium element? So we start with the lowest energy orbital, 1s. So remember, 1s having 1 orbital, therefore it's 1s2, and then followed by 2s, 1 orbital, so maximum 2 electron, followed by 2p, 3 orbitals, maximum 6 electron, followed by 3s, 1 orbital, maximum 2 electron, followed by 3p, 3 orbital, maximum 6 electron, then followed by 4s1. We need to end with valence electronic configuration. So now I give you another example, magnesium. So magnesium is in period 3. Therefore, the highest principal quantum number is 3. Therefore, the valence electronic configuration should start with 3. And magnesium is group 2 element. So it's in the S block, so 3s. And magnesium group 2 having 2 valence electrons, therefore the valence electronic configuration of magnesium should be 3s2. And to write the electronic configurations of magnesium, we start with 1s. So 1 orbital, maximum 2 electron, 2s, 1 orbital, maximum 2 electron, 2p, 3 orbitals, maximum 6 electron, followed by 3s, 2. So this is the electronic configurations of magnesium. We need to end it with the valence electronic configuration, 3s2. Now we move on to look at the valence electronic configuration for group 13 until group 18 elements, the p blocks elements. For group 13, the valence electronic configuration is ns2 and p1. Again, the n here refer to the highest principal quantum number or period. For group 13, there are 3 valence electrons, so 2 valence electrons go to the S subshell and another one go to the P subshell. The last electron go to the P subshell, therefore it is the P block element.
For group 14 elements,
the valence electronic configuration is ns2 and p2. And again, the n here is the highest principal quantum number or period. For group 14 elements, there are 4 valence electrons, so 2 go to the S subshell and another 2 go to the P subshell. The last electron go into the P subshell, therefore group 14 elements are P blocks element. We move on to group 15. So the valence electronic configuration for group 15 elements is ns2 and p3. Again, the n here is referring to the highest principal quantum number or period of the element. For group 15 elements, there are 5 valence electrons. 2 electrons go to the S subshell and another 3 go to the P subshell. Again, as the last electron go into the P subshell, therefore group 15 elements are P block elements. For group 16, the valence electronic configuration is ns2 and p4. And the n here again is referring to the highest principal quantum number or the period of the element. For group 16 elements, there are 6 valence electrons. 2 go to the S subshell and another 4 go into the P subshell. Again, the last electron go into the P subshell, therefore group 16 elements are P block elements. For group 17, the valence electronic configuration is ns2 and p5. Again, and the n here referring to the highest principal quantum number or the period of the elements. For group 17 elements, there are 7 valence electrons. 2 go into the S subshell and another 5 go into the P subshell. As the last electron go into the P subshell, therefore group 17 elements are the P block elements. Now we move on to look at group 18 elements. Their valence electronic configuration is ns2 and p6. Again, the n here is referring to the highest principal quantum number or the period of the element. For group 18 elements, they have 8 valence electron. 2 electrons go into the S subshell and another 6 go into the P subshell. As the last electron go into the P subshell, therefore the group 18 elements are the P block element. So now I give you example on how to write the valence electronic configurations for chlorine. So chlorine is period 3 elements, therefore the highest principal quantum number N is 3. And then chlorine is group 17 element, therefore it has 7 valence electrons. 2 go into the S subshell and another 5 need to go into the P subshell to give us the valence electronic configuration of chlorine as 3s2, 3p5. To write the electronic configuration for chlorine, we need to start with 1s2, 2s2, 2p6, 3s2, 3p5. We need to again end with the valence electronic configuration. So I'll give you another example. Shall we look at gallium? So gallium, it is period 4 elements. So the highest principal quantum number N is 4. And it is in group 13. Therefore, it has 3 valence electrons. So 2 go into the S subshell and another one go into the P subshell to give us the valence electronic configurations of gallium 4s2, 4p1. To write the electronic configuration, we start with 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s2, 3d10, follow the Appel principle, and then 4p1. Okay, so we end with the valence electronic configuration for gallium 4s2, 4p1. Now we move on to look at how to write the valence electronic configuration for D block elements. So for D blocks element, start with group 3 until group 12. For group 3, the valence electronic configurations of the element is ns2, n-1, d1. And the n here is referring to the highest principal quantum number or the period of the element. For group 3 element, consists of 3 valence electrons, 2 go into the S subshell and 1 go into the D subshell. The last electron go into the D subshell, therefore it is a D block element. For group 4, the valence electronic configuration is ns2, n-1, d2. And again, the n here is referring to the highest principal quantum number or the period of the element. For group 4, the elements have 4 valence electrons, 2 go into the S subshell and another 2 go into the D subshell. And for group 5, the valence electronic configuration is ns2, n-1, d3. Again, the n here is the highest principal quantum number or the period of the element. For group 5, there are 5 valence electrons, 2 electrons go into the S subshell and another 3 go to the D subshell. Again, the last electron go into the D subshell, therefore it is the D block element. For group 6, the valence electronic configuration is ns2, n-1, d4. And again, the n here is referring to the highest principal quantum number or the period of the element. For group 6, the valence electron for the elements is 6. Therefore, 2 go into the S subshell and another 4 go into the D subshell. As the last electron go into the D subshell, therefore it is the D block element. For group 7, the valence electronic configuration is ns2, n-1, d5. Again, the n here is referring to the highest principal quantum number or the period of the element. For group 7 elements, they have 7 valence electrons, 2 go into the S subshell and another 5 go into the D subshell. The last electron go into the D subshell, therefore it is the D block element. For group 8, the valence electronic configuration is ns2, n-1, d6. Again, the n here referring to the highest principal quantum number or the period of the element. For group 8, elements that have 8 valence electrons, 2 go into the S subshell and another 6 go into the D subshell. As the last electron go into the D subshell, therefore D blocks element. For group 9, the valence electronic configuration is ns2 n-1d7. And again, the n here is referring to the highest principal quantum number or the period of the element. Group 9 consists of 9 valence electrons, 2 go into the S subshell and another 7 go into the D subshell. As the last electron go into the D subshell, therefore group 9 elements are the D blocks elements. For group 10, the valence electronic configuration is ns2 n-1d8. Group 10 elements have 10 valence electrons. 2 go to the S subshell and another 8 go to the D subshell. Again, the last electron go into the D subshell, therefore group 10 elements are the D block elements. For group 11, the valence electronic configuration of elements is ns2 n-1d9. Again, the n here refer to highest principal quantum number or the period of the element. For group 11 elements, they consist of 11 valence electrons, so 2 go into the S subshell and another 9 go into the D subshell. The last electron go into the D subshell, therefore group 11 elements are the D blocks elements. And the last one, group 12 elements, having the valence electronic configuration ns2 n-1d10. Again, the n here refers to the highest principal quantum number or the period of the element. For group 12, elements consist of 12 valence electrons, 2 go into the S subshell and another 10 go into the D subshell. As the last electron go into the D subshell, therefore group 12 elements are the D blocks elements. So now we move on to look at the example for cobalt. So cobalt is period 4 element, so means that the highest principal quantum number is 4. It is in group 9, so means that it consists of 9 valence electrons, 2 go into the S subshell and another 7 go to the D subshell. Remember, the format is ns2 n-1, n-1. So the n here, the highest principal quantum number is 4. So n-1, so 4 minus 1, therefore give the valence electronic configurations of cobalt as 4s2 3d7. So to write the electronic configurations of cobalt, we need to start with 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. We end with the valence electronic configuration of cobalt.